So looking at 2.2, we're going to look at a few more graphs and ways to display data. And the first thing we're going to look at is called a stem and leaf plot. And so one of the similarities to a histogram is you're going to see the patterns of the data jump out at you, the clusters, if there are any. One of the differences from a histogram, one of the benefits of a stem and leaf is you actually get to see the actual data values when you look at the stem and leaf plot. With a histogram or with the frequency distribution, you're just seeing how many fit into each class, but here you're actually getting to see what those values are in each class. So let's look at what this is. It can be a little confusing to read at first, but all we're really doing is splitting the numbers up with the beginning part of the number here on the left side, and then the final digit, the ones digit, we list them out. So this right here represents the number 78 is in our data. And if we looked up there, there's 78. Now there's nothing in the 80s, nothing in the 90s. That's why those two are blank. Now the numbers in our data, we have 105, there's a 108, and there's 3 109s. And you can look up there and find those. And that's how you read this. Every single digit here represents a different piece of data unless you know the exact data value that's in your original data. So that's one of the big benefits of this compared to a frequency distribution or a histogram is you get to actually see the data values. A drawback to this is it's really not scalable. If you have thousands of pieces of data, you can't list out thousands of numbers like this. It would be really time consuming and overwhelming, where with a frequency distribution, we're just counting how many we have. We could still list those counts out, and that would be scalable to any size of data. So that's the one drawback here for stem and leaf plots. You can also take this, I guess, to another level and do a back-to-back stem and leaf plot where going left and right, you have what we call the leaves, those ones digits. So the same stem down the middle, and then your leaves give you a way to compare data from two different sets. So here's two different law firms. You can see that in law firm B, you have a 90 and a 94, and law firm A, you have a 90 and a 97. And so on. You're reading it the same way, but it gives you a way to compare. And you can see differences here jumping out. Law firm A, we see two clusters, cluster on the low end, cluster on the high end. Law firm B looks to be more of a smooth curve, kind of normally distributed all along the different data values. So this is called a back-to-back stem and leaf plot, and it's used for comparison. A dot plot is another option, and here we actually list out all the data values and put a dot for every single value just above the actual value it is. So again, it's not very scalable if we have lots and lots of data, but you can see the patterns and you see the exact data values because they're all listed out. If you think about qualitative data that doesn't have numerical values associated with it, a great way to represent that is with a pie chart. And we've probably all seen these somewhere in our life, but you can just split up a circle or a pie into the different categories and say how much of the pie each category takes up, what percentage falls into each piece. Another way to represent data is what's called a Pareto chart. It's basically a vertical bar graph, and the graph could be frequencies, it could be relative frequencies, but whatever it's showing, the one twist on the Pareto chart is that the tallest bar comes first, and then all the bars are shown in decreasing order, so you can see the trends visually that way. So this is an example of a Pareto chart where the tallest bar comes first. If we have paired data sets, we can do what is called a scatter plot. So this example here of a paired data set is just the length of a petal from this certain flower compared to the width of the petal for that certain flower. So for each flower you measure, there's a pair of data there, this length and its width. And so you can find, plot the dot for each flower from your data, and you get this, what we call the scatter plot, and it shows all the different data points scattered throughout your graph. And what you really want to look at these for is trends in your data. This definitely shows like an upward linear trend. You can definitely tell as the petal length is getting longer, you would expect the petal width to get bigger as well. And that's what's showing here from the upward trend of the scatter plot. And the last type of one I'm going to show is what's called a time series chart. And that's just when we're showing how something's changing over time. We're just going to graph the values. So have time on our horizontal or x-axis, and then graph what the values are for different periods of time, and we connect those with lines so we can see what the trend is over time. So this is based off of this data set here. We had the years, and then we had our number of subscribers that we're graphing down below. And so just for each year, we graph that number, and we can definitely see that the trend is upward. It's actually been trending upward every single year since we started keeping track of our data.